All right. Welcome back, everybody. Hope you guys had a nice lunch. Just a reminder, before you guys leave, please fill out a survey. We left some at each spot, but if you didn't get one, there's a stack in the back there. So we appreciate your feedback. So if any of you are leaving early, just remember to fill that out. And also the sign-in sheet. Make sure to include your email address. That way we can send out links to the training sessions that will be posted online, and then also the slides themselves. And we will get started with our session 2, Engineering BMP Design. And I'd like to introduce Troy Spade, Senior Civil Engineer with the City of Camarillo. He's a professional engineer with the state of California. I saw he is also LEED AP. I know what LEED is, but I'm not sure what AP is.
Associated Professional.
All right. And then also he's a certified floodplain manager. So another expert in the field. We're really lucky to have him, and I will turn it over to Troy.
Thanks. So I'm not really sure how much of an expert I am, but I definitely have some experience in seeing these things get constructed and what works and what may not work. And I think the important thing to say is that there is no real one-size-fits-all. So let me just ask, everybody have lunch? Everybody had a good lunch? Yes. Okay, so I know after lunch you might be having carb overdrive and start to fall asleep, but don't worry, I got you. We're just going to do a lot of pictures. There won't be a lot of numbers and crunching and whatnot. We're going to do a lot of pictures, but in case you do fall asleep, I do have a plate full of grapes up here, and I'm not afraid to toss them. So we'll get you awake. With that, and I did used to play baseball, so I'm pretty accurate, but we'll get that going. Some of the criteria that we went through earlier on in session 2, which is part 1 of this session. So this is Engineering BMP Design part 2, but part 1 was the actual numbers and the design criteria. We're going to go through some examples that have been built in the field, and I guess some of the problems we ran into, but I guess more than the problems, but also what has worked, what we really see doing a good job. So there are there's things that were brought up early on. There was pre-treatment, right? So David brought up some pre-treatment elements, and so one of the first elements of pre-treatment would be pervious concrete, and he gave you a good example from the county, which was the pervious concrete gutters that they have the dry wells underneath. So there was some ridiculous number of dry wells, which I thought was pretty impressive, where they went down the 15 feet. This is a site that's actually right down the street. If you look at the cross streets, it's Adolfo Road and Cortez Circle, so it's pretty close by. And the blue outline here is actually another project that this was all done of pervious concrete. So this entire site drains, all the impervious areas drain to these gutters, these cross gutters or ribbon gutters in the parking lot, and then they infiltrate into the ground. So it's very similar in method to what he had described earlier. Now, what he had described earlier, I actually have a video provided by the county that we'll play.
5.5 to 6 hours of rainfall at this time, fairly steady. And you'll see the pervious gutter here has no water trickling to this catch basin from this section. So as we go forward, all the water is infiltrating about 30 feet from that catch basin. So here's lot G. It's about 1:40 in the afternoon on December 2nd. So we've had probably a good 5.5 to 6 hours of rain at this point, fairly steadily. So you see here the gutters are kind of filled up. Overall, the system is inundated. Here's one of our observation wells that's underwater. So there is infiltration occurring here on the gutter. It says there's too much water. Remember, this system is designed to only store 0.17 inches of an event or the first flush. So anything beyond that, accounting for infiltration, will essentially overflow and act as standard curb and gutter. But as you see here, as we get closer to this 15-foot wide area, all of that water ends up going to the gutter, filling up the sub-basin with aggregate, the aggregate sub-base reservoir, and none of this water is making it to that catch basin. This is an example of, this is in Lot E, about 2 o'clock in the afternoon, December 2nd. It's been about 6 hours of rainfall, fairly steadily. And this is a unique situation here again. The same thing popped up in Lot R, where we're seeing the system reach its full capacity. Here you can see all the water going into the pervious concrete before it reaches the catch basin. Now there's no flow in this gutter here upstream, but there is flow right next to the actual apron itself. So what we're seeing is all the water coming into the pervious concrete, filling up the entire subbase, not being able to infiltrate quick enough, and then popping back up through the pervious concrete and draining to the storm drain. So this is showing that our system is at full capacity, and we're not having enough infiltration at this point to be able to keep up with the rain.
Okay, so that video actually does a pretty good job of illustrating how the pervious concrete works. And let me go back to this slide because this site was actually developed prior to the implementation of the MS4 permit, but they did do some pervious concrete. I couldn't really get onto this site because this building is now occupied by, I think, the Secret Service, and they have everything fenced off. So they don't look favorably upon people snooping around their site. So I just kind of left it alone. But you can see, and I thought the video actually did a really good job of illustrating the timeline and how early on, all the water was going in and it being able to infiltrate. And then as time went on and during the rainstorm, that less and less of it was able to infiltrate. So I think that's good. One of the things that David mentioned earlier is that with pervious concrete, there is no real pre-treatment for that. And it's basically because the pervious concrete itself is the pre-treatment. So you're kind of taking in the flush and it's going to filter out the fines and the sediment. And then, you're going to be left with having to, I guess, vacuum out the sediment, which is the best terminology for it, but get a Vector truck and try to figure out how to get all that sediment out. And, I guess the wider the swath, the maybe the easier it is, but maybe you get less suction. I'm not really sure how efficiently they've actually been able to monitor the actual maintenance on that, but that is the method to do it. So this is another pre-treatment device, and this is something that we have in hundreds of catch basins throughout the city of Camarillo. I'm sure other cities, other jurisdictions have this. This is a connector pipe screen, which is just basically to remove the trash or prevent the trash from going in to the actual storm drain pipe. So makes it easy. It screens the trash from being able to go in, and then you can go into the catch basin and pull out the trash. But this is one of our diversions that we have in many catch basins, and we require most of developers to put these in if they're doing any development around any of the city catch basins. So we have several projects throughout the city, and I want to kind of illustrate a bunch of them. This is another pre-treatment, and you'll see there's actually two different devices here. So this is filtration, but this is the CDS unit, and so the CDS unit kind of does the same thing that the trash screen would do, is removes the trash, but it also removes some of the sediment, allows that to settle out. And I have another video to show. But this is on a project that's also in the city. I've kind of blocked out, who's done what project, because I'm not really trying to illustrate, engineers or, errors or hey, pats on the back. It's just these are devices that we use, and so they work in some instances, and sometimes they're not as successful. But I have a video that I'm going to show after the actual detail. So this detail up here, I just kind of zoom in on it so you can kind of see what they do. But there's an inlet pipe an inlet pipe, and then it goes through the hydrodynamic separator, and then there's the outlet pipe. And it's just simple details, but they're fairly flexible. That you don't have to have a straight inline. You can kind of have your outlets off to one side, or they're fairly flexible. So the video is contacting YouTube. Or not. Oh, there it is.
Stormwater regulations often require treatment of runoff before discharge. This can be a challenge on sites where there is limited space for an above-ground solution. The Contech Engineered Solutions CDS Hydrodynamic Separator is a below-ground flow-through treatment device that uses multiple treatment processes, including swirl concentration and continuous deflective separation, to screen, separate, and trap trash, debris, sediment, and hydrocarbons from stormwater runoff. The treatment process begins as stormwater enters the system through one or multiple inlets. The inlet flume guides the treatment flow into the unit's separation chamber, where water velocities within the chamber create a swirling vortex. At the heart of the CDS system is a unique indirect treatment screen. Unlike traditional screens that can easily become clogged, water velocities within the swirl chamber continually deflect debris off the specially designed screen to keep it clean. The combination of swirl concentration and indirect screening forces floatables and solids to the center of the separation chamber. 100% of floatables and neutrally buoyant debris larger than the screen aperture are trapped in the chamber, and sediment settles into an isolated sump. Pollutants remain in these sections of the unit until they're removed during maintenance. Stormwater then moves under the hydrocarbon baffle, and the treated water exits the system. The baffle acts as a wall for hydrocarbon containment and prevents agitation of hydrocarbons when high flows spill over the diversion weir. During high-intensity events, the internal diversion weir directs flows greater than the design storm around the treatment chamber. The treatment capacity of the system is not diminished during high-intensity events. The design of the system ensures settled material captured in the sump does not escape, and floatables cannot wash out of the separation cylinder. When the storm event ends, the water surface is returned to the outlet pipe elevation. The CDS system should be inspected at regular intervals and maintained when necessary to ensure optimum performance. Maintaining a CDS is a simple process that can be easily accomplished in less than 30 minutes for most installations using a vacuum truck, with no requirement to enter the unit. Many stormwater treatment systems require multiple structures to direct the design flow rate to the treatment structure and bypass high-intensity storms. The configuration flexibility of the CDS allows it to replace multiple structures, providing significant savings. The CDS can accept multiple inlet pipes at a variety of angles. The configuration flexibility makes the CDS an ideal solution for retrofit applications where compatibility with existing structures is necessary. The CDS system is often used as a standalone treatment device for large drainage areas. It is also an excellent solution for pre-treatment of downstream systems, including infiltration, detention, and rainwater harvesting systems. The CDS system will remove and contain sediment, trash, debris, and hydrocarbons before they enter the downstream system, which will improve water quality, ensure proper system functionality, extend the life of the system, and provide for easier maintenance by concentrating pollutants into a single manhole. With over 40,000 units sold worldwide, lab and third-party field tests, and approvals from leading regulating agencies, including the Washington State Department of Ecology, the New Jersey Department of Environmental Protection, and the Canadian Environmental Technology Verification Program. Contech's CDS system has been providing dependable stormwater treatment for over 20 years. Please visit www.conteches.com/CDS for more information on CDS, including technical information and a collection of case studies. The Contech CDS system, an innovative solution to stormwater treatment.
Troy, could we applaud?
No? Okay, so these are actually components of a CDS system that went in right down the street. So this is the Tessa Robles project, which is on Adolfo and Cortez. No, Camino Ruiz. And this system went in, I think we showed the plan. This was the plan from that set where they called it out. Later, I'll actually show you kind of an overview plan of where some of these elements are on that site. But this is actually a pretty good picture. You can see the internal column. You can see kind of the vortex portion of it. You also see the large pipe diameter inlet where, if you don't have a pipe that needs to be that size, you can put a smaller pipe in and configure the inlet. There is notes on it. The inlet pipe must be centered. It is fairly self-explanatory for contractors, but there's always good need for have inspectors on site to make sure that they're doing it right, because even though it's called out fairly clear, they'll miss it. So this is actually a sheet from that set where there's several different items going on. So you'll see over on this area there's a detention basin, and you'll see that here there's the biofiltration. So if you notice item 13, furnish install storm filter model. So this is that other solution that was on that first cut sheet, and I'll kind of go into that now. I think there's another video for that, but this is the detail that was on that other sheet that shows kind of how it's laid out, and this is the filtration media. These are like little modules that can get inserted in, so storm filter cartridge, and those cartridges can be configured, I'm pretty sure, to filter out certain pollutants, and depending on which pollutants is your target, the media would change within those little cartridges that you would put in. Typically, the ideal situation isn't to always use mechanical devices for filtration, but if you see this site, and if you drive by this site later, you'll see that this site is extremely packed. There's not a whole lot of space, and we'll show another area of this site that shows that it's even more impacted than it looks from this picture. So we're gonna do a video of the filtration.
Stormwater regulations are increasingly calling for more robust treatment levels. In addition to the removal of suspended solids, many regulations now require best management practices to remove significant amounts of nutrients, metals, and other common pollutants found in stormwater runoff. To help meet these regulations, Contech developed the Stormwater Management Storm Filter, a stormwater treatment device comprised of one or more structures that house rechargeable, media-filled cartridges that trap particulates and absorb pollutants such as dissolved metals, hydrocarbons, and nutrients. During a rainfall event, stormwater enters the structure through the inlet pipe and is directed to an energy dissipator to minimize resuspension of previously captured pollutants during the treatment process. Stormwater passes through the filtration media and begins filling the cartridge's center tube. When water reaches the top of the cartridge, the float valve opens and filtered water is allowed to drain at the design flow rate. A one-way check valve then closes, activating a siphon that draws polluted stormwater evenly through the filter media and into the center drainage tube. Filtered water then discharges out of the system through the under-drain manifold. When the water level outside the cartridge approaches the bottom of the hood, air rushes through the scrubbing regulators, releasing the water column and breaking the siphon. The turbulent bubbling action agitates the surface of the filter media, promoting trapped sediment to drop to the vault floor. This patented surface cleaning mechanism helps restore the permeability of the filter surface during drain down and between storm events. The filter media in the storm filter cartridges can be customized to target site-specific pollutants. For example, in applications targeting phosphorus, Contec developed Phosphosorb, a unique filter media designed specifically for applications targeting high levels of phosphorus removal. The structures that house the filter cartridges can be configured in a variety of ways to accommodate a wide range of flows, project-specific footprints, and variable hydraulic conditions. The peak diversion storm filter provides high flow bypass and flow base treatment in one structure. Water enters the vault through an inlet and is directed to a treatment chamber containing the filter cartridges. During peak flows, the internal weir allows high flows to bypass treatment, eliminating the need for an external bypass structure. The volume storm filter is designed to meet volume-based treatment regulations and is often combined with outboard storage, such as corrugated metal pipe, to provide, treat, and draw down the water quality storage volume within required drain down times. The storm filter is available in multiple cartridge heights to meet site-specific hydraulic needs and is available in different upstream configurations, including roof drain, catch basin, curb inlet, linear grate, and infiltration. The storm filter can be used in a number of applications, including commercial and residential development, infill and redevelopment, and stormwater quality retrofit applications. Highways, airports, seaports, and military installations. Pre-treatment for downstream detention, infiltration, and rainwater harvesting and reuse systems. Designed for predictable maintenance intervals ranging from 1 to 3 years, the storm filter has been optimized to make maintenance easy, cost-effective, and time-sensitive. All storm filter structures provide access for inspection, media replacement, and washing of the structure. With over 150,000 cartridges in use and performance verified by multiple regulatory agencies, including the Washington State Department of Ecology and the New Jersey Department of Environmental Protection, the storm filter is a proven stormwater quality treatment product. Please visit www.conteces.com/stormfilter for more information on storm filter, including technical information and a collection of case studies. The Stormwater Management Storm Filter, an innovative, reliable solution to stormwater management.
So one of the common themes that you may remember even from when David presented earlier before lunch was he talked about a system that had kind of an overflow for when you have a peak flow. You're going to filter through these either drainage devices or filtration devices or even swales, bioswales or whatnot during the low flows. But during peak flow, you need to have kind of an escape route for some of that water so that it doesn't inundate the system. And both of the Contec items that were shown both took that into account. And this isn't meant to be a commercial for Contec. It's just an observation that they simply already considered that as part of their design. So this is another project that we did a couple years back. This is the Mini Cooper dealership over off of Daly Drive. This one's interesting because this is a channel, and this channel's several, I don't know, 8, 9, 10 feet deep, right next to the site. And this site happened to be in the flood zone. So they were limited in really what they could do drainage-wise to get the drains to work, because the nearest outlet it's right next to it. So they developed this, basically it's a bioinfiltration, and David had mentioned before lunch that he had not seen one, and this is, in theory, this is exactly what this is, and I'll explain a little bit more about it. But out here in this landscape area, there is a bioswale that all of the rainwater from the surface of the dealership runs off and through these curb inlets that I'll show you pictures of too. And they run off into the swale, and then they go into a pipe. So you can see kind of the detail of the actual underneath filtration, but here's the swale itself, and what you're not seeing is the pipe that takes it down into that area. And then there's a bunch of rock down there with the roughly about 40% void volume, which is able to capture and retain that water and then let it infiltrate into the ground. So it's underground percolation basin, but there is the bioswale on the surface that shows how it's getting there. So the bioswale here next to it captures it, and then it inlets it into the infiltration basin. So this is what it looks like. It captures the water from, you can see the parking lot right here, and it lets it run through all of this vegetation into this area, and then eventually it goes down into the pipe, perforated pipe that's in there, gathers it, and lets it flow into that infiltration basin. So it's kind of a neat little design. It actually is flourishing. It's working well, and it looks nice. So I know we have a maintenance and access agreement on this where they're required to maintain it, but they're actually doing a really good job with maintaining this one. And it's one that you can't really see on the surface, how it's working, but you can see on the surface that it looks well maintained. So we got another video. This is a discussion about dry wells. So it's kind of simple, not a lot there, but that's a proprietary dry well device. David, before break, actually described their whole system of dry wells that they had on the government center site, which is another type of dry well. But this one's a proprietary device. Can work. You see how it functions. Kind of a two-step system where it fills up and then lets the sediment kind of come out in the first dry well. We had a project that had a dry well on it, and I'll get into that a little bit later with lessons learned. So, so this is right next door to that other. This is right next door to this one. So this is the Mini dealer, and then this is actually the BMW dealership. So they liked the look of the bioswale that was on the Mini dealership, but they didn't have the same need, and this one came about after the MS4. So they did some different things on this one. This one is, in fact, it's more of an underground infiltration trench. So this one has the bioswale, but underneath that there's a pipe that collects the material, and then it goes to an infiltration trench, much smaller area. So you'll see the detail for the infiltration trench. But again, if you look at the way that it looks very similar to the other one. The main difference is that you actually have a drain inlet. And so as the water runs off from the parking lot through the curb openings down into here, it's going to run through, the rock, it's going to run through the low points, which is going through these grass, and eventually it'll make its way into the drain inlet. So they look very, very similar, but they're actually functioning very different. So, as mentioned earlier, as far as the stormwater BMP design infiltration, a geotechnical investigation must be conducted when evaluating infiltration rates, and you have to figure out if you have that or whether you don't. And there may have been some of that discussion with this as far as not being able to infiltrate as much or as fast of a rate, which is maybe why they went with a slightly different plan. But anytime you have two properties owned by the same people right next door to each other, and they can make the BMPs look nice at the same time, because I think that looks really nice. Everybody agree? That's good. So it looks nice and it functions. It does what it's supposed to do. And it's being well maintained. I mean, other than looks like a rock found its way onto the grate, but not a big deal. So,
Troy,
yes.
quick comment on the soil's permeability thing.
Mm-hmm.
The technical guidance manual is actually that, a guidance manual.
Yes.
So there are specific soil permeability requirements spelled out in that technical guidance manual. However, since it's guidance, a professional geotech or soils engineer could override those restrictions. Like I think it's a ½ inch per hour permeability. A geotech could override that if they believe they can get the permeation they need over the 72-hour period. So I just want to put that out there because a lot of people go by the book, strictly by the book, recognize that it is a guidance manual.
Yes. And keep in mind that we've been talking a lot about the pretreatment elements. Pretreatment must be provided for any filtration and infiltration facilities. So it's kind of like removing the sediment, removing the trash. Those types of things are pretreatment. Pretreatment may also be provided for water quality detention basins and other treatment control devices. So, for instance, that storm filter, you may add pretreatment onto that so not to inundate the maintenance that would be required on a storm filter system like that. Sometimes with infiltration, you have you have basins, you have trenches, bioretention. Sometimes you have it with or without an underdrain. With an underdrain, it's not really infiltration as much unless the drain is situated higher to allow some of the lower flows to infiltrate, whereas you don't want it to inundate an upstream system if it doesn't infiltrate fast enough. Okay, so this next one is modular wetlands, which is very, very similar to what the BMW dealership has. So I'll go ahead and start that video. So, I mean, that's a proprietary device that basically acts the same way that the whole design worked on that BMW dealership, the way they had set up that wetlands area. Okay. So, post-treatment or after pre-treatment, right? We talked about pre-treatment. We got into some of the treatment devices, but basically anything after pre-treatment to me is post-treatment, because pre-treatment's still treatment. This is actually another picture of the Carl's Jr. That David mentioned earlier. This was a facade improvement. What was that? Yes, just a facelift. What's something that anybody sees that stands out on this picture? Just yeah, the concrete, right? This runoff coming over the curb and into this area. Does this look pretty clean? It doesn't look clean at all. Again, this whole project was done as a facelift, basically a facade improvement. So there was no conditions for stormwater BMPs, no construction BMPs, no nothing. We happened upon this and thought, wow, it's not really a facelift. But yeah, we kind of got their attention, and then we got them to come to the table, and we did end up getting them to do some things, clean up the site and put some BMPs in place, as well as they did put some trash screens on some adjacent catch basins for permanent use. So while we couldn't condition them to do a lot of other stuff because it was after the fact, we were able to get them to do a few things. This is that same project right down the street here at Verdugo and Camino Ruiz. So this system is, I don't know, I refer to it as milk crates, but it's the Echo Rain system, and they have their tanks and whatnot. So this is a picture of as it was being constructed, and you can see how deep they are into the ground. You can see the freeway over there. They're down there pretty deep. They've got their sand at the bottom, and they're putting these milk crates in, and there's some fabric on here. We'll get into that in a little bit. And then their manhole to access and maintain. You have another one over here. But what do you see how tight this site is, right? This is the wall to the site, and the freeway is just on the other side. And then you have this whole system, and the storm drain, you have a storm drain over here, and on the other side you have water and water. You have two water pipes on the other side. And then there's a 20-foot Camarosa easement that goes from somewhere beyond the wall to somewhere over on this side. This was a challenge, and we took some pictures of as it was being built. So there's kind of first stage, and now you start to see a couple different manholes in the picture, right? But you see the milk crates, and then you see the fabric on top, and then the sand and whatnot. Now, I'm not so sure that there's fabric underneath this one. I think it's just the sand layer. The fabric is more for on the sides. But as they kind of enclose this whole deal, you can see they filled up the entire basin area, and this is to infiltrate most of this site, which, as I said, was pretty tight. So they take all the impervious runoff from that site, and eventually it finds its way into here, and then they cover it up. I wish I had a picture of the way it currently looks. I didn't take one of those. But there's actually a park on top of here. There's a dog park kind of over in this area, and then there is a just kind of a pedestrian path with some kind of a basin, a little on the surface basin over in the other area. But our city council decided that they wanted trees in this area. Not sure where they're going to go, because there's not a lot of places to go. And here's kind of a detail of what one of those milk crates looks like. Now, this is probably a different manufacturer than the Echo Rain system, but kind of the same thing. And they eventually have these circular cutouts where you can pop it out and have a pipe go in and to drain out if need be. Let's kind of go back. So let's see. This is probably the better picture. There's a building. If you go out to the site right today, there's a building that's probably about this close to here. So there's no room to really put trees over here. So their city council wants trees. They're going to try to fit some trees over in this area before, somewhere in between the easements and the actual basin. We'll see how that works out because we're not sure. But they want trees, so they're going to get trees. This is another project on the other side of town, and this is just a kind of a detention basin where the runoff from different sources along the streets comes in. There is these two inlets up here on the street that captures the water and allows it in here, and then it kind of fills this up in a rainstorm and then infiltrates into the ground. The good thing with this area is it actually does have pretty high infiltration rates, so this ends up being a pretty good infiltration. But there's a fairly decent sized storm drain system throughout this area. There's actually 3 66-inch pipes. And they run, one of them runs like right along this street down through. This is, I know it's kind of hard to see, but back in this corner, this is another basin on the same site. So you can see this whole development has multiple basins, and the way they have them set up is a little bit different. But this one inlet, comes in from the street, and this one's kind of right in line with this sand filter. So that other basin is back in here. So now there's a sand filter, the same project. And this sand filter is actually done very similar to what David described before lunch, which is there is kind of a choker on the system. So you have like I think it's a 48-inch pipe that comes down the street for this system, and they choke it down to an 18 or a 24 to get the flow, all of the low flow to actually come into here. If it goes higher than that, it's going to bypass the system and go straight into the 66-inch pipe. But it comes into the sand filters, and then it fills up these bays, and then it eventually is able to kind of filter out. And if it fills up so much, it'll go into the overflow and then back into the system. So it will recharge, but it has its built-in safety nets.
Is that fenced off? It looks like they don't even allow access to it.
I'm sorry?
Is it fenced off? It looks like they don't allow access to it. Maybe it's the depth issue they brought up earlier.
It is totally fenced off. There are gates on it. There is access into it, but it is meant to stay fenced off. It is deeper than 18 inches. There would be some safety concerns if it was full of water, but there's no concern as far as drawdown time on it. But it didn't always look like this. One of the things I'll talk about in a little bit is about when to put some of these systems online, during construction, because this project's still under construction. And this sand filter has been probably online for maybe a year already, maybe a little bit more. So this is actually the plan that shows that sand filter system down here. And if you notice, you see this berm, slopes down and down, but you have another basin over on this side too. So, but the sand filter system, it comes down through this pipe, and then it gets choked off into here, and then it fills up these basins, and then it eventually, if need be, it can find its way back into the system. But any high flows are going to bypass, and they'll go down through this line. So this is a different angle of that same basin. So it's just looking from the other side. The first picture I was standing over here. This picture I'm over here. You can see where it kind of comes in, and if everything were to kind of flow and fill up, then it's going to go back into here and then out into the street where the main line is. Okay, so some learning experiences. This is probably the best point, because we have learned probably more than we wanted to from some of these. This is an early picture of the sand filter. So early on, January of 2017, they put the sand filter online, and it got completely covered with sediment. So there was a lot of construction activity going on, a lot of winds blowing, and between that and what was draining in there, it became completely inundated with sediment, and it covered over the sand. So they had to kind of rip out a lot of the sand. They had to redo a lot of that. And of course they didn't like it, but they were trying to get occupancy to some of their facilities, and these are on the plans as treatment devices. And so this area was actually an area that was being used to treat some of the areas that they were trying to get occupancy for. So we told them that they had to implement it, and we knew that they also had to kind of keep it clear and free of any debris and whatnot. And unfortunately, it was a lot harder for them to do than they thought, because not just the sediment down in here, but trash, that ended finding its way into the fenced off area. So this is kind of a dilemma that we're fighting with a little bit right now. Mike, what's your take on this?
There's two ways we can do this. We can either tell them that as part of occupancy, like what we did was, as part of occupancy, we required these to be offline before we granted the occupancy. Now we're kind of looking at these things as, well, yeah, they failed to implement proper erosion sediment control. Shame on them. But now we're kind of thinking maybe in the future, because we know that's probably going to happen again. Maybe we should keep these offline, have the structures put in, but keep them offline until final occupancies and final stabilization. What is everybody else doing?
Have any input from any of the other agencies? Mike?
Well, aside from the sand getting still on top, and then they having to go down several inches to clear all that sediment and not contaminate the rest of the sand, which is a special sand. It's not just sand, it's just not ordinary sand. It's specced out. The slopes are stabilized with plants, right? And then in the course of the transition from from construction to HOA, a lot of the times the HOA won't put enough attention to those slopes, and they end up dry or overtaken by weeds, along with construction debris from the nearby site. And that's been a problem. So.
Okay. Any other agencies have?
If a project is being constructed in phases, you don't want stuff to be online for just parts of the whole project. You need to accept the entire project when it's all complete. That's how we do it.
So you're saying put the BMPs online at the end?
At the end, yeah.
And you still allow occupancy in the
Yeah,
earlier phases,
yeah.
you just wait
It-
until the end?
Yeah, because they need to be online when the project is complete, not for each individual phase.
Yeah, I'm not really sure which is the right way to go. I think if they have proper construction BMPs, that might be the right way to go. If they don't have proper construction or sufficient construction BMPs, it might be real difficult to make that claim, because ultimately you could get an illicit discharge fine or penalty if it's going into the storm drain that it shouldn't be. So that it is a bit of a problem. I guess learning experiences as far as like infiltration BMPs. The technical guidance manual lays it out pretty good, but it states they shouldn't be placed in high-risk areas such as near service stations or gas stations, near truck stops or heavy industrial sites. So if you're going to be infiltrating into the ground, it's probably not good to have it near like where there's chemicals going, draining onto the ground regularly. I think Mike had a scenario that is recent, right?
Yeah, so there's a gas station that was proposed outside of Ventura, and they proposed an infiltration system. It was a proprietary infiltration system, like a contact system with pretreatment. It was really nicely well done, but they proposed an infiltration for a gas station.
So I mean, that's up to the agency to kind of keep track of those things and know. As much as the engineer who's designing it should also know that that's not okay. The agency is ultimately approving the plan, so probably not a good thing to do. Was that?
So then I have a question. So
Sure.
We haven't come across it specifically as of yet. So in the gas station scenario, you're essentially saying, or you tell the gas station, well, no, you can't do infiltration because we're concerned with the pollutants. So So if that goes under technical infeasibility, are you now requiring the gas station to now treat 150% of the water runoff, even though they could have just infiltrated a lower amount?
Yes.
You're passing on more expense to them.
Well, unless they can theoretically actually infiltrate. Now, a lot of gas stations are basically postage stamps, really small facilities, right? But our technical guidance manual actually states that in order to do infiltration, let me see, I might even have it here. Yeah, so in addition, infiltration BMPs must be sited at least 50 feet away from slopes steeper than 15% or alternative setback established by geotechnical expert. So it actually calls out a setback from slopes. I believe it calls out the same 50 feet away from any of like service stations or any of those areas that would be high pollutant concerns. So if their site is sufficiently large where they can infiltrate in a different area, but they're not actually taking the drainage from that high contaminant area over to there, then it might work. But otherwise, they're going to probably have to use a proprietary device and treat 150%. Wet pools is something that's in, and I'll continue on through this, but wet pools is something that's in the technical guidance manual, and in Camarillo, we don't have any wet pools. Does any other agencies throughout the county actually have any wet pools or wet ponds? Yeah, I'm not aware of any. I mean, I think they create a scenario that we're not real comfortable with vectors. So this is another picture of that same sand filter back in January of 2017. This is the way it looked like as it got inundated from the incoming before it started to flow into where it was supposed to go. But you can see how bringing it online a little early made it not so efficient. That's a good picture. This is a dry well. And it was a dry well. This is actually out on Flynn Road, so it's not too far from here. And I have a plan of this. I guess I'll go to the plan and we'll come back. So the plan showed just the casing, just the top surface for them to access. So it's observation well detailed, right? So you have the top casing, and then you have the casing for, just a PVC riser to take the drainage down and let it infiltrate into the dry well here, into the rock, the gravel. And the way they did this, when they put the rock in this dry well, is they kind of dumped the whole load of gravel. And I guess at some point it became wedged in against the sidewalls of the dry well and the pipe that was running right down the middle of it. And it left a void space below. And eventually when cars started parking on the parking lot, it started to sink because it started to settle. And this is what we ended up with. So we had to have them take out a section. You can see the white paint marks. We had to have them take out a whole section of this and redo that dry well. And this time they put the rock in and lifts. So this is one that hopefully we've learned from, and we make sure that they do this more efficiently next time, just to make sure that you don't have this construction related issue. The BMP itself, the design it's functioning now. It's probably fine. The way that it's filtering water seems to be working. Unfortunately, it's just the way that it was constructed was not sufficient for what it needed to be. So this is This is another bioswale that was brought online probably a little too early. This is out by the high school, the new high school, the Rancho Campagna High School that they built. So this date looks very similar to the other date of the sand filter, but it's not. It's a whole year prior. So it's 27th January 2016, and the other project was a completely different area. But so we, they built this, but what you can see back here is that this back here is not even built. There's a lot of dirt, it's a lot of sediment. And then even beyond the fence line, this is still farm field. And so they had a ton of sediment come in here. And lo and behold, actually below all of the sediment is riprap. Like, how far below that sediment was all that riprap buried?
It was like about 13, 14 inches
So
of sediment. I didn't even think there was riprap there.
Yeah.
Better dig it
So
out.
there was a good amount of sediment that had built up, and it filled it filled the basin, the swale, the bioswale, with sediment where you couldn't even tell what was there or that there was anything there. This is kind of a couple years later. This is more recent. You took this one like 2 months ago.
Yeah, about 2
So
months.
you can see it's probably not being maintained real well because there's a lot of grass and vegetation and stuff that's in there that probably
Sediment's
doesn't
back
need to
in
be.
there.
But again, this is the way it looked when it was completely inundated with all that sediment, and that's the way it looks now. So I mean, even though it may not be maintained very well, it's probably serving its function. It's probably filtering pretty well right now. But you can still see even today, there's farm field back there, and then this hasn't been finished off. So a lot of that was just maybe bringing it online a little too early while there was still a lot of construction going on, a lot of sediment in the air. Because I don't really think that most of that sediment ended up getting in there from the construction site. If I could show you how far away the construction site is, it's probably not coming in from the ground travel. So that bioswale is right here, and the inlet to it is this pipe that comes through here. This is the grass fields at the high school, but way probably somewhere over here is the actual high school that was being constructed at the time. So it's probably not that close. And then if you look at where the pipe is, where this was actually collecting drainage from, it's several thousand feet away. It's probably unlikely that was all coming in through the pipe. But it's a rather big storm drain system, 60-inch by 24-inch double barrel. So this is Grass Creek, and we had a good learning lesson with Grass Creek. This is and basically this is in an area. There was an apartment complex and there was a berm built, and we needed an access road to get from where the road was up here down to where there was the access point for where the outlet of the stormwater was. And this was their ultimate design, was to put this Grass Creek Road in, and we told them we needed to have access through construction to be able to get out there to where it was being an outlet, because the construction time frame on this apartment complex was supposed to be about two and a half years. It ended up being closer to 3.5 years. But we couldn't not have access during that time. So this is a picture of kind of the way it looked a couple of weeks after the initial install. And one of the problems was that they kept running these big earth movers over this stuff, which doesn't work too well. And you end up starting to see stuff like this. And you can actually see, this is a great picture because you can see the tracks from those earth movers kind of coming over here, and they're doing whatever they're doing. But these things are kind of modular, they're just little squares. And then what was supposed to happen was they were supposed to plant grass down the middle, and then all the drainage that was supposed to come down filters through that. They didn't plant the grass. They put the squares in place, but they didn't plant the grass. So nothing was really locking it into place. This is the same grasscrete area. Yeah, so the drain is kind of outside the redwood header. Kind of makes it a little interesting for drainage. Also keeping it contained. But you can see the actual rutting that's going on here and how deep the rutting actually is. Fairly steep for such a small area. So 5 months have elapsed since the first picture. It's actually the same area. Looks like a war zone, right? It doesn't look anything like it should look. But lo and behold, we got them to rebuild it, and that whole strip is what it looks like now. Actually, it looks really good. It's functioning, so the grass is holding. Everything seems to be operating. It serves as an access road. Anybody can drive on it, other than earth movers. Probably wouldn't take those over it, but it does what it's supposed to do, and it does look nice. I mean, it's certainly better than if you have this amenity for the apartment complex over here, which is just like a little park area. And as opposed to having a road right next to it, full paved road, you have this grasscrete road, which serves its purpose, right? It's just it's an access or emergency access to a point on the other side of the berm. It's not used frequently. It's not like people are driving over it all the time. But it certainly looks a lot better than if it was just paved. This is actually a plan detail of that. A little grid, the way it's supposed to look. You can see the way the redwood header was supposed to be, and then the way these things are supposed to be flush with the redwood header. And even on the initial install, they weren't installed that way. They were left low, and had they even installed it correctly, they probably would have had to come back out and rip it out and rebuild it. But this is Spring Oak Road right here, and this is the access point to that coming down. So you can see that kind of the grid material, but that goes all the way down. So this is a plan sheet. Right here within that system, you can see the curvature of the road. But that access road goes all the way down this length. So some other failures, and these aren't necessarily in Camarillo, but these are things to be concerned with. And it's not to call attention to any one manufacturer or anything. I actually don't know who's the manufacturer of some of these elements, but this is a parking lot where these storm chambers were underneath. And if that's a proprietary name, I apologize. It's not intended to be that. It's just these arch structures were underneath, and they thought that they could actually support the parking lot. And it looks like it's relatively shallow. It didn't work. The parking lot collapsed. We know of another situation, and I never did find those pictures. It's near San Diego, and I don't know exactly which development anymore, but they use these kind of the milk crate type structures, and they put it underneath a parking lot, and it started to kind of give way, and it caved in. So, I showed you this type of system where we have right down the street. And what they did on top of it was they didn't put it in a parking lot, they actually built a park on top of it. So it's not like there's going to be a lot of really heavy equipment driving on it, not a lot of like trash trucks or anything like that. It's probably a pretty good location for it where they have it up the street. I don't know what the situation was here, but I know it failed. It doesn't look good. So you have these arch systems that there's a good amount of volume that goes underneath there, and you can see how that works. Store the water and let it drain, infiltrate through the ground. That's good. I love this one. This is probably from one of these the sites, but this is like the Golden Arches, right? So, but I don't know that I would actually do this. I mean, maybe it could withstand it. I'm not sure that I would, trust it to necessarily, fully loaded loader with, this construction equipment. Looks like it's a dangerous situation. This is an interesting system. So I'm going to call attention to something right here, and I don't know if you can see it on your slides or if you can see it on the screen. Maybe this is a little bit clearer. Can everyone see what this says? It says DYODS. Anybody know what DYODS stands for? There you go. So what does that mean? What does that mean to you? Okay. So this was a system that was spec'd out for a project in California, and they took these cut sheets right from the Contact website. The only major problem is that note number 6. Note number 6 says Contact C40 or C45 non-woven geotextile required wrapping trench only. So this system was to take in a whole bunch of water and then let the water infiltrate out into the ground. And unfortunately, it will definitely get out of the pipe. The problem is that fabric is going to trap all the sediment and the fines and everything inside that system, making it not very useful after a while. There's not going to be real easy ways to design that. Ultimately, the engineer should have used a different cut sheet, should have used one that didn't have this fabric, because the fabric's useful in some circumstances, but not for what he was trying to use it for. He was trying to infiltrate and get the fines out within the system, but he was going to trap them in. I think you guys have a different cut sheet, right?
Yes. And in theory, you are absolutely correct. I'm Mark Baker with Contact. That fabric should allow the water through. However, the point is very well taken. We want the fines to go through along with it, and that's going to slow it down and it's going to speed up the process. So it's not the plan in California. And generally speaking, when these designs come to us, when we see them, we take that fabric off the design and resubmit the drawings with the fabric on the sides and on the top. I think it's good for everybody to, understand that all of these tools that we find on various people's websites are a tool, but it really makes a lot of sense to talk to whomever the manufacturer might be at the same time, because there are tricks to things that we know. In this case, it's not even a trick. It's the fact that this is a tool for the whole United States of America. And in many cases, you've got clay and you've got high groundwater, and you're putting fabric on the bottom of an excavation to make sure that high groundwater does not bring the clay fines up into your detention system. So there's a lot of reasons, but I guess if there's a point out of it all is, A, contact us, please, or Oldcastle, or whoever you might be working with. And B, this is why we give drawings to the contractor for submittal and approval before the manufacturing process starts. Because you saw a problem and said we have to deal with the problem and got dealt with. But some people don't. It's just kind of a quick sign off and they go. So I mean, it's definitely important. It should be well considered.
It's kind of similar to what David brought up earlier about the plastic liner, where it was on a cut sheet, right? I mean, the guy probably pulled it right from the website, looked at it, and said, "Okay, we're going to try to keep this out," but didn't necessarily notice that that note actually calls out what that liner is, because it's a thin line. I mean, unless you're paying attention, it's a thin line. Now we caught it in the field because I think Mike got called out for an illicit discharge, right? Was it?
It was actually tracking.
Oh, it was tracking.
I'm curious to see the devices going in. And he was actually, this is actually when it was after we had already told him that they needed to take it out. And then the fabric.
So yeah, he went out and he saw the fabric. He saw the fabric here on the sides, but you can see the gravel on the bottom, and they're deep in there. I mean, they have shoring, but you see the size of these pipes. They are not small. That is a huge detention system. That is a lot of storage there. Ironically, that same project, the gravel that they brought out was in plastic bags. Small little plastic bags with rounded edges. It wasn't like jagged edge gravel. It wasn't actually anything to do with the spec that was called out on the plan. So we ultimately did get them to drop truckloads of gravel, and they put it back in right. So eventually they did take all the fabric out, and they put it in. They put it in correctly. This is a February 2017 photo of the Springville projects, and that sand separator that we talked about earlier is down in this area, and the berm behind it is over there. But do you see what this looked like? So remember those pictures that from the sand separator were actually from January of 2017. This is only probably a week, maybe 10 days later, and this is what that whole area looked like. So it was all inundated because up above this is all Spanish Hills, and everything runs down into these other basins. You actually can see another basin right down here, and then eventually it goes underneath the road and outlets over to here. And they have an ultimate system which is supposed to pick this up, but they didn't have it constructed. And they figured, okay, I guess when they did their construction planning, they didn't necessarily look at it and think that it was going to rain, because it never rains in Southern California. But it, lo and behold, did rain, and they weren't ready for it. And they had Venice for a while. So this is, I think this is a week later. Yeah. So this is a week later. So this is like after, you can still see gray skies. This is blue skies, but this is still what it looked like, 5-6 days later. And that's more what it looks like now. So it's definitely dried out and under construction. There's a lot of activity going on. So are there any questions? Any comments about learning experiences or, yeah, Jane?
I got a learning experience project to share with the class. Awesome. We had an industrial project very close to the Santa Fe River in the county of Ventura, and it was very, very good percolation, and it was right for an infiltration basin fields that we used at the Storm Tech chambers. And everything was done right. Everything, it was on the rock, it was deep enough, the infiltration was good, backfill was good, everything was done, everybody did their job. But something that I think was a coordination item might have caused a problem. The infiltration values or the percolation values were so good because there was a lot of junk fill in there. And that wasn't really known until the whole site was excavated, and the field folks from the geotechnical firm said, this has to come out and go back in. This is under a parking lot. It has to be, recompacted. So these soils underneath the infiltration basin field were compacted to a much tighter degree than they had been when it was tested. So it became problematic because the infiltration rates weren't happening the way they were originally designed to do. So
we actually had a similar situation, similar experience. We had a project that they did the percolation rates, and I want to say it was some really high rate, like 72, 80 inches per hour, 80 inches per hour. And we had told them, I mean, it seemed kind of high for us, like that whole area just seemed kind of high. And we had told them, okay, well, make sure that you test in a couple different areas and make sure that's the case. Mainly because we knew what was on that site before, and when they demoed a portion of that site, they didn't demo everything, and what was on that site was they had underground tunnels. And so they came down, they knocked off the top parts of the walls, and then they filled everything in, right? So there was still like basically concrete channels underneath there. And when they took the perk rates, they were perking probably right over one of those concrete, the concrete channels, these little underground tunnels. And sure enough, like the perk rates were great, Lo and behold, then they overexed the site when they came out and they graded it and they did the grading for the whole site. And then they ran into all of these underground tunnels and they said, hey, did you know all this was under here? And we were like, yeah, we did. We told you about it. And lo and behold, they actually graded the site, they compacted it, and then they did new perk tests, and they didn't get anywhere near those rates, the same perk rates. But yeah, they were still sufficient. It just wasn't like 80 inches per hour. I think it was somewhere like 15, 16. Yeah. So, any other, yeah?
Just curious, the Grass Creek driveway?
Yeah.
They showed, was that like a pre-treatment filter strip or just a way to offset impervious areas?
That area, because of where it's at, has no official drainage. There's no way to get that to drain anywhere, so it's basically it's its own infiltration area. Okay. Everything else on site is kind of part of the whole drainage system, and that piece there, it's just kind of in no man's land. It's just, and because of where it's at, right next to the freeway, as it's coming down, it's at the lowest spots. There's no way to get like an under drain or anything in there. So it's mainly to take any overflow off the street that would be coming in, but mainly it's just for its own percolation.
On that Grass Creek, did you have post-construction maintenance requirements to irrigate, maintain the vegetation and all that?
Yep. Yeah, there is irrigation in the area. There's sprinkler heads. I could probably go back to some of the pictures and maybe see some of the sprinkler heads, but it's pretty beat up. It's pretty beat up. Any other questions? Oh.
How'd you manage to get the school district to play ball?
For the it was a bit of an arm wrestling match. We had regular meetings, but we really tried to establish a good relationship with them up front, and we spent a lot of time throughout, not just the early part of before it was under construction, but as it was being constructed, having meetings, making sure that they understood that, look, we're not here to make their life miserable. These things are going to cost them in the long run. We want them to have a product that gets going but doesn't upset the neighbors. I mean, they're plopping this in the middle of a neighborhood that, it can really create some problems. But it was, I think a lot of it was just relationship building and, building that trust with them, because otherwise it is kind of difficult sometimes to get them to do something when they know they're not necessarily required to. Any other?
Yes. I think it goes back to the one site where you had the sand infiltration area on the bigger track. It sounded like it was brought online
early before they come into phase of construction. I think my question is that I'm assuming that the site was big enough to have a SWIP. So they would have their own SWIP on there that the owners would have to take care of. So even if you brought it online, it seems like the maintenance of it would still be under the guise of the SWIP. So they'd have the responsibility for maintaining it.
Yeah. So, yeah. I guess the thing is with those, with the erosion control and sediment plans. Let's say your project is this big, right? So you have perimeter controls and you have all your stuff set up for this big, right? But then they're only trying to get occupancy on a small portion. And so this portion is the area that now that's kind of creating that to go online. But all of their perimeter controls aren't really doing anything for the inlet control that's going direct from that location. So it's almost like they have to have a kind of an interim SWIP that does smaller areas within there if they're going to do phasing, and that's something that was not done. But I think if we really look at it and analyze what went wrong, it definitely is something that if they had proper construction BMPs set up for the smaller areas, the smaller tributary areas, it's absolutely something that could have been dealt with the construction BMPs. I just don't, when an engineer is actually designing a site, especially that large, there's 224 homes in that site, and it's multiple streets, multiple phases. Each phase, there's 3 phases of the whole overall track, but within each phase, then there's at least 8 phases of construction, right? So you're talking about at least 24 phases of construction. I think one of the phases has 11 or 12 phases. So you're a lot of phases, right? And the engineer doesn't know how necessarily they're going to do the phases because it's not even in the sequence that they put on the plans, right? It doesn't say, oh, this is phase 1 and they're going to go phase 1, phase 2, phase 3. The way that the developer ended up doing the phases was like phase models, phase 10, phase 6. So for the engineer to try to prescribe that, there's no logical reasoning for him to be able to do that other than maybe the sequencing if the developer was going to do it by the number order that they assigned it to. But even in the middle of construction, they flip things around. They're like, oh, wait, let's do this as 6 and let's do that as 9. What does it matter? I mean, it's all out of order anyway. But yes, your point well taken. If they had proper construction BMPs, it should not have happened. I think the problem is that many times they meet the letter of the law with the erosion control sediment of the SWIP, right? But not for the smaller areas in which they're actually building. So, yes?
Were they relying upon that basin for sedimentation?
No. If you remember, let me see if I can go back. So this picture here is actually right adjacent to some of those phases that were that the sand filter would have been also filtering. But this is actually the direct drainage area to the area that they were occupying. I think the inundation of the sand filter was mainly because if you remember the last 3 slides where I showed you the kind of the panoramic view of the overall development, you saw how it was inundated with water. I think it was just they didn't have enough of their construction, not just their BMPs, but the actual storm drain devices and the overflows. They didn't have enough of that set up to be able to contain it, to withhold it. So they had kind of temporary devices that were kind of diverting flow around ultimate systems, and it was, if everything was constructed all in sequence and all at the right time, I think it would have been fine. But because it wasn't, and they brought the sand filter online before, and really in the scope of where that sand filter is, it is the last BMP of all of those. You know, you have a bunch of these basins like this that are supposed to be first in line trying to get some of that drainage. That sand filter is actually the last one, the farthest downstream, and it just, because it was already constructed, they brought it online, and that's why it got hammered. Any other? No? Good. And I didn't have to use any grapes. That's good.